Hello, my name is Isha Nagareddy, and my project for the Congressional App Challenge this year is OptiCare. OptiCare is a mobile application that helps in the diagnosing of eye diseases through novel point-of-care methods utilizing machine learning technology. So what exactly is the problem that OptiCare aims to help solve? Of the 2.2 billion people who suffer from vision loss, 1 billion of them suffer from vision loss due to the inaccessibility of eye care. Their suffering could have been avoided. The main barriers include economic inequities, limited transportation options, and lack of eye care providers in rural areas. To help combat this, OptiCare was created. OptiCare aims to increase accessibility to glaucoma and cataracts point of care diagnosis through the development of a mobile application and cheap complementary 3D printed tools. The target audience of OptiCare is medical professionals in rural settings or underserved populations who can use OptiCare to then signify and also continue as evidence for their own diagnoses. In addition to this, it's also the general public who may be faced with one or more of the following challenges: cannot afford eye care, no eye care providers in the area, and lack of transportation to an eye clinic. The tools and technologies that were used were the following. Programming languages Swift and Python were used, database was Core Data, ML model integration was done using TensorFlow Lite, and the IDEs Xcode and Google Colab were used. Now moving on to the demo of this application, when you first open OptiCare, you can look at resources. These resources contain videos and also a short caption explaining exactly how you can assemble the novel 3D technology created. In addition to this, moving on to glaucoma diagnosis, we can first take or upload a picture of the fundus of our eye. Then we can press Analyze and a machine learning model is run. After the machine learning model is done running, we can take the severity questionnaire since it seems there's a high risk of developing glaucoma. In this case, we can now answer the severity questionnaire based on the following questions, and it will tell you next steps and potential treatments based on your answers. Now, going back, we can also analyze our IOP if taking the fundus of our eye is not possible. Now, when we're measuring IOP, what happens is a large sound is played. After this, we can start recording the decibels that are reflected from our eye. Now, as seen in a previous research paper, there is actually a direct relationship between the strength of the reflection coefficient from your eye and the intraocular pressure of your eye. Using this relationship, we can then measure and see if there's an abnormal increase in the intraocular pressure of your eye over time, as seen in the following graph. Now, if there is an increase in intraocular pressure that does seem abnormal, this application will help tell this based on the slope of the graph that is created. In this case, there are no signs of glaucoma, and that's mainly just because demonstration purposes. Now going back, we can also help diagnose cataracts. What we can do is press yes and then take or upload a picture of our eye, as seen over here. Now we can press Analyze once again and another machine learning model is being run. In this case, there seems to be a 100% chance that you have cataracts, so you can go ahead and take the severity assessment again. And finally, here are the accuracies of the machine learning model. The cataracts model had an accuracy of 87% on the validation set, and the accuracies for the glaucoma models were 86% and 80%. Thank you for listening.